Hello everyone, so welcome back to my YouTube channel. In today's video, we are going to solve today's problem of the day, that is 3558, a number of ways to assign age weight 1, part 1. So we are given a tree which is represented by a 2D integer of age. It means that we are given an age list in which the first in which is a 2D array and we have two elements in it. That elements, it is u and v. It is generally representing a n-weighted graph of u and v. There is an edge between nodes u and v. It is not given whether it is a directed graph or a directed edge or undirected edge. So we will consider it as a undirected edge. Initially, all edges have a weight of 0. You must assign each edge a weight of 1 or 2. So initially, it has a edge weight 0. And we have to assign the edge weight as 1 or 2. The cost of a path between any two nodes u and v is the total weight of all edges in the path connecting them. We can select any node x at the maximum depth. Return the number of ways to assign edge weight in the path from 1 to x such that the cost is odd. It means that if I am considering this node and I am considering this node, so the total number of nodes, the total number of edges in this loop from 1 to, suppose this is x. So from 1 to x, the path from 1 to x and total cost should be odd. So here the initially it is 0. So what we can assign? We can assign it as a, instead of 0, we can mark it as a 1. We can mark it as a 1. So our by this way, this edge becomes odd, and the number of ways to solve to make it odd is only 1. Suppose first of all, if it was only two nodes was present in the graph in the question, but we have to find the maximum depth. So at the maximum depth, there can be two possibility, 4 and 5. We can choose any one. So let me choose 5. I have chosen 5 as my node, and let us process it. So there are the depths are 2. So if I want this sum to be an odd by choosing only 1 or 2, so how can I choose? The first possibility is I can choose 1 here, and the second I can choose 2 here, or I can choose 2 at the first place and the 1 at the next place. So how many ways are there? There are two ways to solve this. There are two ways to get our answer as odd. Number two, by doing this, okay, suppose if there was three ways and we can choose only one or two. So in how many ways we can add these numbers so that it can be an odd number? The number of one ways should be, I can add only all one. It can be 2 to 1, 2 to 1, or 2, 1 and 2. So these are only the ways by which I can have the sum of the digits, sum of the edges as an odd. So it is 4, and here you can see it is 2. So by using the concept of binomial expansion, we can find uh, conclude we can conclude that the total number of edges which can make the sum of all the edges from 1 to x is nothing but 2 raised to the power n minus 1. This should be the answer. There is a mathematical derivation behind this, that how this formula has come by using the binomial coefficient. But you can see from the pattern, if there was only one node, the output was only 1, and the second time the output is 2. For having 3 nodes, the output is 3. So for having two nodes, the output is 2. For having one node, our output is so. By observing the pattern, you can also get to this result, that is 2 raised to the power n minus 1. So we have to find the depth, maximum depth of this tree node, and then we have to just return the 2 raised to the power n minus 1 as our result by doing modulo, because okay, some yeah, because we have to do the modulo, because the answer may be large and it cannot store, it cannot fit into our long. So we have to use a, mm, so how we are going to solve this problem? First of all, we have to do some traversal. So we can do any of the traversal. I will traverse in this graph by using a BFS, breadth first search. Okay. So I have given 1, 2, 3, 4, and 5. So I will start. This should be my -1 will be my x, or I can say maximum depth. Let us start from -1. First of all, I got my index 1. This is my q. I will push uh, q1 into the queue. Then I will iterate after pushing into the queue, and I will start my loop from while PQ is not empty. So I will start iterating in the priority queue. So after finding the priority queue, so first of all, I have to find the level. It is the first level. So I have to increase x from -1 to +1. That will be x equal to 0. So we got 1 because 1 is our 0th order. So we have find the first depth, that is 0th. And after iterating in this one, I have to push 2 and 3. And this will be my level 2. So on, I will start pushing 4 and 5, and this will be my level 3. You can I will show you the code how we are going to do this, but eventually we will do this type of thing. This should be our marker for division, and by this process I will find that our d is 3. After finding that our d is 3, maximum depth is 3, I'm just going to return 2 raised to the power 3 minus 1. Okay, so I did some mistake, I guess. Okay, so the first order was 0th, and then after it will be 1, and then it will be 2. Sorry, so the here instead of 2 raised to the power 3 minus, it will be 2 raised to the power 2 minus 1. So this will be 2 only. So we will get our output as 2. So let me show you the code. Okay. So I have sorted. You can sort it or not. You can ignore this step because eventually we are just creating. Instead of first of all, I am converting the edge list. From edge list to I am converting it to the agency. Oh, sorry, it is given as the edge. Yeah, edge list. I'm converting into the agency list. So first of all, if I have given so first of all, what was the 1 2 1 3 3 4 3 5 1 2 1 3 3 4 and 3 5. I was given this, I guess. Yeah. So first of all, I will convert this edge list into the agency list. So one will have 2 and 3 as the output. Then uh, then 2 will have 1, 3 will have 1, 4 and 5. 4 will have 3 and 5 will also have 3. So we will get this agency list. After okay, so first of all, I'm going to find the max edge also, because after finding the max edge, because it can be only so it can be the maximum number of nodes that is present in our vector. So as you can see that in this array the maximum number is 5. So I'm going to do the one base indexing. So I have to take 5 plus 1, that is 6. So the I am going to initialize a vector with six boxes, or I can say with six data in, and they will we have 0 1 to so on. So I have fifth index, I will get this type of agency list. This code will create this agency list. After creating the agency list, I am going to do a simple BFS. So this is a BFS. This code is a BFS code by which I am going to find the maximum depth of my graph. So by this process, I will find my maximum depth. So how we are going to do? First of all, PQ, I'm going to push one only, because it is given that all the arrays start from 1 and it can go to any number. So the starting index is always fixed, that is 1. So I'm going to push 1 in our array. So after pushing in the array, I'm just going to mark it as a true because I have already visited. So after visit, I have already visited this array. After visiting, I have to check whether PQ is empty or not. If PQ is not empty, then this loop will follow. First of all, find the level size. It means that find the PQ dot size. So initially, PQ size is 1. So first of all, and then increase the x plus plus. It means increase the level. I have started the level from -1. So this level is called 0 level. And then just do a simple iteration for I equal to 0, I less than level dot level size, I plus plus auto p pq dot front. It means that, okay, so this will be my for loop. In this for loop, I am just extracting 1, and then I'm traversing all the neighbors of 1, and then I'm going to push into the element. So I'm going to traverse the level of, I am going to traverse this numbers. This is 2 and 3. Then I will push in the priority queue, or not priority queue, in the queue. So after iterating from 1, I will get 2 and 3 in my 2 and 3 in my queue. So in the next iteration, the size of the PQ will be, the size of the PQ will not be 1, it will be 2, because here you can see that the size of the PQ is 2, and I'm going to increase the maximum depth as 1. Now I will check. I will just start I will just start traversing from 2 and check what are the neighbor of 2. It is 1. Is it visited? Yes, it is visited, so I will do nothing and I will continue. Then I will check 3. Whether 3 is visited, 3, what are the neighbor of 3? That is 1, 4 and 5. And is 1 visited? Yes, 1 is visited, so do nothing. Is 4 visited? Okay, so after pushing into the vector, I have to mark as 2, 4, this 2 and 3. So you can see 4 is visited, no, 4 is not visited. So do one thing, mark it as a visited and then push into our queue. So I'm going to push into the queue and then check 4 and 5. 5 is visited or not? 5 is not visited, so mark it as true and push it into the our queue. So and as you can see that we are just checking them in our loop, so we are eventually popping them out, so they will be deleted from our queue. So in this level I have only 4 and 5 in my input. So in the next iteration, the size of the PQ will be 2 only, because you can see that there are only two elements, that is 4 and 5. So we have only two elements as 4 and 5. So the size will be the same, that is 2. Then I will increase the depth from 0 to 1, that will be 2. And then I will check what are the neighbors of 4. So you can see that neighbor of 4 is 3 and neighbor of 5 is also 3, and both of them are visitors. So we will don't do anything, and we have found our maximum depth. So after finding the maximum depth, just return 2 raised to the power 2 minus 1 and it will be answered. But as you can see that the constant of this problem is less than or equal to 10 raised to the power 5. So we cannot go by this solution, because first of all it will be by using an inbuilt power function, it will lead us towards a time limit exceeded error. Moreover, we have to return the answer as a modulo. So by doing this process, we can actually cause an integer overflow, because the numbers cannot be contained by int or long for this problem. So we have to take modulo in each step. So we have to write our own binomial binary exponential code. So you can see this. This is our basic template. All of you know that how. I hope you all know about how we can write this code. So basically, it is like this. Like if I'm going to find the power of a cube, what I can write this as a into a square. Okay, and if it is a raised to the power 4, I can write a square whole square. So as you can see this, the power is getting reduced in 3 minus 1. That is okay. So power is getting reduced by 3 minus 1, and here it is getting reduced by 4 by 2. This should be 3 minus 2 by 2. Okay, so so I'm going to just pass this. So basically, okay, so I hope you know this about this, how to write a solution, a binomial exponential code, or you can Google it. So it's a very simple code. Okay, so by this way we can solve this problem. So basically, this problem demands us the two concepts. The first concept is finding the depth of the uh, binary tree, or I can say a graph. So by this, first of all, find the depth of the binary tree, and the second is we have to find the binary exponentiation. It means that we have to find the power. So if you know these two concepts, you can easily solve this problem. So in the time complexity of, obviously we can solve this problem in the time complexity of big of n, because you have to iterate to find the maximum edge, then creating the edge list. By this way we can solve this problem. Also you have to do the BFS. So doing a BFS will take us big of v plus e number of time complexity. So that eventually it will be the time complexity of big of v plus e. So this is a solution of today's problem. Let us submit the solution in the lead code portal. As you can see that we have passed all the test cases, and it has been successfully submitted on the lead code. Thank you.